Hi everyone, in this video we're going to start learning the basics of strings. So you've probably realized that we've already been working with strings in this class. So for example, I bet the first thing we probably did was something like write print out hello world, and as you probably realized, this is a string. Everything inside those quotes. This is a new line character, it's one character, but otherwise we could count this up. I don't know, there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, because that new line is just one character. So this string, we would say it has 14 characters in it. And we can also use strings to define our constant variables as, or I guess they're not really variables, they can't change, but our constants using the define preprocessor directive. So say I wanted to do something like name and save the name Bob there, and then I could maybe, if I wanted to print hello Bob instead of hello world, I can use my string placeholder. That's the %s. So before we've seen %d was our int placeholder, etc. If we want to print something as a string, we use %s. And now I could pass in my string name, and we could just go ahead and see this. We should recompile. And there we go, we got hello Bob as we hoped. So in order to, I guess, strings might seem simple and familiar, but in C, they can actually be sometimes a little confusing. So first off, we don't really have a separate string type. What we have instead are arrays of characters. And it kind of makes sense that this is how strings are stored. But say I want to, let's say, declare a length 30 string. Well, what I'm going to do is I'm going to say I want a size 30 character array. So I'll say char, and let's say I call this string var, so this could be any variable name, but I'm just going to choose string var to call my string. And here I've now allocated memory for a length 30 string with 30 characters in it. But we'll see there's a little gotcha there too. I can initialize my string using something like this. Let's say I call this string str, and it's going to be length 20. I can initialize it this way, maybe initial value, and I would then need a semicolon. And then let's think about, so we understand that this is a character array, but let's think more concretely about how this is stored in memory. So this is my str character array, right? My array of chars. And here I've just labeled each slot of this array with its index. So we would say the I was at index 0, and we could even confirm that by doing something like, why don't I just say, what is, so I'm going to print a character, so use my, the start of my string is, and I'm going to say, use my character placeholder, and now I can actually, because it's an array, I can just get at that first slot and let me add a new line character and a semicolon, and now I can compile and run, and I'm just going to ignore that warning. So the start of my string is I, so I wasn't just lying to you. I do indeed have an I stored at index 0 here. So we can also see how, okay, the space is also stored. Space is taking up index 7. And then another thing I want to point out is we allocated 20 spaces in our array, but we're not using all of them, right? And so I've just represented that with a question mark, and that just means that's uninitialized data. So I could access that just like I can access parts of an array that I haven't filled, but there's no guarantee on what's there. So it might be a 0, but it also might not be a 0. And then finally, one thing I want to point out is this \0. So this is a special character, and it indicates the end of a string. And so how C knows that your string is done is from this \0. So like, you know, we already saw that we can use this %s to actually print out a string, but we didn't have to tell it how far to go. So the whole string is, and maybe I'll use my %s here, and I'm just going to pass in str, the whole thing. So the only way that C knows to print out just the string initial value instead of, you know, initial value and then whatever is hanging around in these last slots is because of this \0 character. So again, just to convince ourselves that this is real, indeed, it only printed out initial value even though we allocated 20 slots. And so it's going to be really important to understand that these \0 characters indicate to see where to end the string. So as you probably guessed, we can make arrays of strings. Maybe I can declare one like, I'm going to make a character array and it's going to be called friends. And maybe there are 3 friends, and I can set who these friends are. And so I already made a mistake here. So by saying 3, there are 3 friends, but I also need to allocate how much space do I need to hold each name of each friend. And a lot of times when you're writing your programs, you're gonna define some like max string length, max friend name length. So it's kind of long, but let's say that these friends all have short names, so there's only 10, they can only be length 10, and now I might put max friend name length here. And so now what have I done? I've allocated space for 3 character arrays, each of which has length 10. And now maybe Bob was one of them. And Kathy. And let's put a semicolon. And so here, this is one way that I can make an array of strings, and I might do something like for to get, if I wanted to print all these out, I could do something like for int I equals 0, I less than, I guess I'll just hard code my 3 because I know I have exactly 3, and I'm going to increment my i's, and then I would use my string placeholder again to print these out if I wanted to. Friends. And here, so this is a 2-dimensional array, but I just need to access things via the first slot, right? So if I look at friends at 0, that's going to be the length 10 character array that holds Bob, holds the character array Bob. Or we could say the string Bob. And let's recompile. I'm just going to get I'm going to get rid of this that we're no longer using because, or maybe we never used it. We just saw that we could declare it like that. Because I don't like warnings. And now we need to run. And we successfully iterated over our array of strings, aka an array of character arrays. So now I just want to first point out one thing that you're probably going to want to use in both the lab that's coming up and in program 2, which is just for formatting strings. So if I want to, and this actually works for any data type, but I don't think we've actually needed to use it really. I guess I could use my friends. Yeah, that'll be good. So let's say in my output I wanted to print these so that they were not aligned left but aligned right. So I want them all to line up on the right. So I can do that using, I guess I'm gonna copy this for loop. So if I'd like, I can use Shift V to highlight lines in visual mode, and then I can press J to copy the entire for loop, and then I press Y to yank, and then I'm going to press P to paste below. So if I press P here, I paste below. I'm going to press undo just to show that I can also paste above by doing Shift P, and that pastes above. So I can choose whether I want to paste below or paste above, or I can just move my cursor and always use paste below. So I want to right align these. So I think, let's say, so what I can do, so we saw that for floats, so I guess, okay, we're going to right or left align. So we saw that for floats, we could do something like %. So let's say, or for doubles, our placeholder was %f. But if we wanted to just do 2 decimal places, we could do 0.2. So if we want to align, we just do something like 2. And that's going to say take up a column size of 2. But we probably don't want column size of 2. We probably want a column size of something like 10. And so let's see what this, I just don't remember if this is going to left or right align. So we're just going to have to try it out. So, all right. So when I said +10, what it did, so this was my first loop where I didn't have any special formatting going on. In my second loop, I said, I want to add enough spaces in front so all of these take up 10 total characters. And so if I want to right align things, I use a positive number there, maybe just as further illustration. So that was giving it 10 spaces, giving the column width of 10. Let's try 6. And we can see the difference. Okay, I need to run it. So now, so this was a column width of 10. Now we had a column width of 6, but in both cases they were right aligned. So now let's try something. And if we need to left align them, so currently they already are automatically left aligned because friend is, you know, every time it prints out, it's the same. But it's possible, maybe say we printed, instead of saying friend, we just print them twice. So print name twice, but left align. So now, instead of saying friend colon the name, I'm going to say the name again. I'm just going to say the name twice. So %s, and so let's see what this looks like if I don't do any of my justifying. Oh, I need to pass in two copies, right? Friends at I. Misspelled it. Okay, so now let's run it. So now we can see that these aren't lined up in any way, right? So here they were the names were lined up on the right, and now I want to line these up on the left, even though what's before them is different lengths. So if I want to line things up on the left, I use the minus. So let's try minus 6, because we saw that worked. Okay, I guess, oh, that's left aligning. Okay, so I didn't really need it on I'm not sure if I needed it on my first one or not. What happens if we take this out? Yeah, so by putting this -6 in both, I'm filling that entire thing with spaces. So this is printing out the first thing, but with enough spaces to fill 6 slots, and then again with enough spaces to fill 6 slots. So really what I don't need, I guess we can run this. And we can, so we see that this was filled with 6 spaces, and so then when Bob was printed again, it was printed after 6 total characters here. So you're going to need to use this justification or alignment strategy in, I believe, in your lab and in your program. So I think it's also in a hint in the program at least, maybe in the lab too. So finally, I also want to show how scanf is useful for reading strings, but it can also kind of mess us up. So let's go over to another another file here, and it's going to be figure 8.2, and this is from the book. So here we have a simple program that's going to consume some string data from the user. So, we also have our string length here that's set to 10. We have a string for department. We have a int for course number. We have a string for days, and we have an int for time, right? And so what this is going to do is it's going to ask the user for a department code, a course number, the days, and the time in a certain format, and it's going to read them. And then it will print those out. So there are a couple things to note here. Let's compile it. I'll compile it to program. And then we can run it. So say I do this, COSC 2060, Monday, Wednesday, Friday, 1410. And so now it has saved and processed what I entered here. And so some things to note. Okay, so we read in the department as a string. We read in the course number as an int. We read in the days as a string, and we read in the time as an int. So first off, you'll notice that we needed the ampersand, which is the address of, only on the ints. And that's because if you recall, we've been learning about pointers. Arrays are actually pointers. The variable that we store for the array is a pointer to the front of the array. And so scanf, as we now understand, it needs to take in a pointer to the variables that it wants to assign, because it can't return us, suppose we didn't have a concept of passing by reference, then scanf couldn't return us more than one thing at a time. But because we do, it can assign as many variables as we want, and it can also return us how many things it successfully set, which we use all the time in our while loops, and so that we can process an unknown amount of input. So you'll notice that department, there's no ampersand here, right? Because it's already a pointer. Another thing that you might notice is we couldn't just save all of this as one string. So this code works because we've got a string for the first thing, an integer for the second thing, a string for the third thing, an integer for the fourth thing. If instead we had done something like this, so say we just wanted to read the whole thing as a string. That sounds much more convenient, right? And we're going to save that to, let's say, I'm going to make a new variable. It's going to be, I'll call it course, and I'll just give it lots of space because I'm going to read in the whole line that the user passes to me. So now I can pass in course, and I don't need my ampersand because it's already a pointer because it's an array. And now let me recompile. I have some warnings because I have some unused variables, but that's okay for now. And so now what happens if I realize I did not add a print statement, so we don't know what's happening yet. Now let's print course info is, and so we just want to print that whole line back. Course, and let's see what happens. COSC 2060. Okay. So here we see that even though we entered this whole line, we only got the first thing. And so the issue here is that scanf is only going to read, if I just give it one variable, it's only going to read until white space. And so that's why we need to do this in this way, where we have a variable for each one. Or maybe we have a loop and we continually loop and we get each input as it comes to us. But scanf will only read a string to white space. And so we could have it would have also worked. We could have read all of these as strings. Oops. Although, and this would actually run and it would read them in, but we'd have to save the variables as strings instead of ints, so I'll just change these back. So the point here is that scanf will only read a string. If you have only one variable, it'll only store to the white space at that variable. So one final thing to understand to really drive home the fact that strings are pointers because they're arrays let's look at program, oh, it's string 0, I think. So here we have one final example. We have a string blue, and we have another string, and it's also blue. And so if we ask ourselves, is the variable A equal to the variable B, or is it not? I can write this code, so it's going to print equal if this evaluates to true, and if it evaluates to false, well, it'll print not equal. So let's try it out. Yeah. So it tells us not equal. And the reason is that what's being compared here, oops, what's being compared, addresses, right? A is the memory address where we're storing this character array. B is the memory address where we're storing this character array. And since we declared them separately, they're different memory addresses. And so when we say A equals B, we're comparing memory addresses. I'll say memory here. And so in another video, we will see how we can actually compare strings. I mean, you could write a loop that went over each one. You know, we'd have to say if A at 0 is B at 0 is equal to B at 0. I guess it's not a loop. And A at 1. So this is how we would compare the actual values. But do not fear, we will see that there is a function that can do this for us and get us the behavior that we want. So that is an intro to strings.